I don't care. It's not your classroom, it's my classroom. And who's queen in here? I am. Alright, so today the first part of our lesson is operations with radicals, adding and subtracting radical expressions. We have done this before. Let me just reiterate that we have done this before. Does everybody understand? Okay. Not saying you're not allowed to ask questions. I'm just saying maybe think about it before you ask it. Alright, so on the adding and subtracting, you can only add or subtract when the expressions have what? The same. Look at us go. Making my heart proud. The same radicands. Come on, Morgan. Come on, baby. We're trying to do this lesson. You moving slow. Let's go. Alright, so in example 1, A, do these all have the same radicands?
Yes.
Yes, and what is the radicand? 2. So all you do is 5 plus 7 minus 6. What's 5 plus 7? What's 12 minus 6? So it's 6 root 2 is your answer. Magic. Alright, any questions so far? On example B, can you combine the square root of 3 and the square root of 5? No, but can you combine the square root of 3 and the square root of 3? Yes. So, what is 15 root 3 minus 11 root 3? Bless you. 4 root 3. Bless you. Alright, and then we have negative 14 root 5 plus 6 root 5. And what is that? And that's your final answer. Does anybody have any questions? Yes, no, baby cell?
No.
Okay. Please look at this baby page. I would like you to do numbers 8, 10, 31, and 30. 8, 10, 30, 31. So for 8 and 10, did you get 8 root 3 and then 11 cubed root 5? Look at us. Do we need another minute on 30 and 31? Okay. What are you talking about? I don't want to know. Shouldn't have even asked. It's fine, Patrick. I know that you're just being you. Alright, what is 3 root 5 plus 4 root 5? Okay. And on number 31, what's 6 root 3 minus 2 root 3? Magic! Any questions when you have the same radicand? Can you please get off your phone? Act like you've been in my class before. Alright, example 2. Mark this out. I don't know what happened. Alright, now, are either radicands the same? But can we simplify these? Yes, so let's break down 18 and 32. Can anybody tell me the biggest perfect square that goes into 18? And if you say 6, I'm going to give you push-ups. Alright. 9 and 2. What's the biggest perfect square that goes into 32? 8 is not a perfect square. It's 16 and 2. Alright, now looking at this, what's the square root of 9? And what's 3 times this 2 right here? So we have 6 root 2 plus. Alright, what's the square root of this 16? And what's 4 times 2? So we have 8 root 2. Does everybody see where we got those numbers from? Are we sure? Do I need to walk through it one more time? Yes. So the first thing I did was I broke my radicands down. For 18, I said the biggest perfect square that went into 18 was 9. That gave me 9 and 2. For 32, I said the biggest perfect square that went into that was 16. And I got, can you wait just a minute until I finish explaining? Thank you so much. 16 and 2. Then I said the square root of 9 is 3. 3 times 2 is 6. And then 2 wants to stay in the house to read Harry Potter. Then I came over to my 16. The square root of 16 is 4. 4 times 2 is 8. This 2 wants to stay in the house to read Harry Potter. Does that help? What's your question?
I had a question about like the test in schools, like the ACT is funny.
Does that have anything to do with what I'm doing right now? Are you interrupting my lesson to ask me that? Okay. Yes, Manny.
What's that last rabbit? That last square root?
This? You see how we marked it out?
I didn't see that.
Look, they're alive.
We marked it out. Okay, now can we combine these two? What is 6 root 2 plus 8 root 2? Questions? Oh no, but you got to get it together. Like, you're making everybody annoyed.
No, I have focus.
I don't think you're understanding what I'm saying to you.
No, I wasn't saying sorry.
I don't think you're understanding what I'm saying to you.
Oh, okay. The father.
Congratulations, you're getting on everybody else's nerves. Stop. Alright, now let's look at 12 and 48. Are 12 and 48 the same number?
Oh,
Patrick? We have to simplify. Alright, so what does 12 break down into?
4 and 3.
If you don't know your perfect squares, make a card and stop saying 6 and 8. Those are not perfect squares. Does everybody understand? You should still have this note card somewhere. And if not, write it on a piece of paper. Stop saying stupid numbers. Alright, what's the biggest perfect square that goes into 48?
16.
16 and what?
3.
Awesome! Alright, now does everybody see where we got those numbers from? Are you sure? Okay, now let's take the square root of 4. What's the square root of 4? And what's 2 times 4?
Alright, I got the answer.
And then what's the square root of 16?
4.
And what's 4 times 6?
Negative 24.
Alright, and now what's 8 minus 24?
Negative 16.
Negative 16 root 3. Dun da da dun.
This is easy.
I know. Any questions? Are we sure? Pardon?
Why'd you make it through? She didn't make it easy.
I don't know. Do you want me to make you cry? Would that be better? Do you like when I make it easy, do you freak out and think, oh my God, what's about to happen? Can you work on number 9 then? Do number 9.
Wait, you have to simplify all the problems?
Yes. Is 36 a perfect square?
No, I was talking about like, you only simplify all.
You only, right. So you simplify the ones you can.
Yeah.
If you can't simplify it, then why would you simplify it? Saxon, I'm gonna pour this hot tea on you. Maybe next year I'll create a random question box, and all the random questions that you have, you put those in the box, and then I answer them the next day.
That'd be fun.
For real, for real?
For real.
No.
Yes.
We're on here. Look at us go. Oh, are y'all ready?
Yes.
Yes, no, maybe so.
Everybody else.
Thirteen root 5 plus 18.
You don't add 18.
You can't add them.
There's a 1 inside.
18 doesn't have a radical with it.
So it has no.
Yes. Didn't we write that in our notes at the beginning?
Okay.
We did. Look right here. You can only add or subtract when the expressions have the same radicands. I was there. I wrote it down. Did anybody else besides Saxon and his joyous celebrating over here get 13 root 5 plus 18? Hey, good job, the Fab Four. So what happened with the rest of us?
I did 20 and 4.
Okay, so right here, the square root of 36 is,
36 is
6.
and so 3 times 6 is, that's where that came from. 80 breaks down into 16 and 5. The square root of 16 is 4. 4 times 2 is 8.
You can't do 20 and 4.
You have to use the biggest perfect square. Does that help?
Wait, 36.
What?
For 36.
The square root of 36 is 6, so it's just 3 times 6. Alright, let's look at number 36. Try that one without me. That's a plus sign, not a division. You can do it. You can do it.
26.
See?
Yeah.
See? Are we done? Anybody besides Cheney's creepy growl?
Yes, Saxon's good.
I say yes.
Shall I get 4 root 3? Okay. 27 breaks down into 9 and 3. What's the square root of 9? And then say you have root 3 plus 3 root 3, and 1 root 3 plus 3 root 3 gives you 4 root 3. Okay. We're going to have to do more than that. 27 breaks down into 9 and 3. The square root of 9 is 3, so you have 1 root 3 plus 3 root 3, which gives you 4 root 3s. It's just like x plus 3x is 4x. I do want you to do number 37, and then we're going to do 2 more together to make sure that we understand what's going on, because y'all scaring me. You take the square root of 9, and it moves outside. $37. Bless it. Are we done? Did you get 2 root 5?
Yes.
Did everybody get 2 root 5?
Yes.
Do we need to do some more? Okay. So I'm going to write on the back of this, on the back of my notes, I'm going to call it example 2C. And I get the book out to make sure that I write down the right examples. It is 75,000 degrees in this room. I'm sorry, are you not entertained?
No, I was just.
Alright, 4 root 54 plus 2 root 24. Do you want to do it together?
No.
Okay, try it without me. Please get your perfect square note card out or write them on a piece of paper, something. Does anybody in here want their Angry Birds project before I start chunking things? Alright. Are we done with this problem? Did we get 16 root 6?
Good.
Woo! Did anybody not get it and we need to do one more? Alright, I really love talking to myself. Let's do one more. Should I go crazy? Let's go crazy. We can do it. We can do it.
Is that 245?
Yes. Blessings. Blessings. Yes. Good job.
Bless you. Bless you.
Bless you.
Wait, no, one more time. It must be like one once. You left
Thank you. Yay! So we feel good about these? We can move on to the next section? Alright, let's move on to multiplying. Again, we have done this before, so we should be able to multiply. Can you multiply this 3 and this 2 inside the radical together? Can you multiply the 2 and the 6 together? Can you multiply the 3 and the 6 together? But can you multiply what's on the outside? And can you multiply what's on the inside? Magic! So you have 3 times 2 is?
6.
Root 2 times root 6 is? What is root 2 times root 6? The square root of 12. Root 12. Not just 12. You can simplify it. And what does it simplify into? 12 root 3. Ta-da! Where did Saxon and I get the 12 from?
Multiplying
2 times 6. And where did the 2 come from?
4.
Woo! Can you do B without me?
Yes.
All right. And just think we're almost done with this lesson.
Yes.
How exciting is that? Are you sure?
Yeah, because what I was going to ask them, and I was like, more. So probably not a
You're like, self, that's a multiplication sign. Eighth period wouldn't talk to me yesterday, so I had an entire lesson to myself. And I even said, self, what would you do here? And answered myself because they wouldn't talk. It was so much fun. 8th period.
Oh, I thought you said when I said, I thought you said talking to the guy. I was like,
Mr. Hester did think I was talking to myself, and I was like, well, I actually was. I was teaching on a video. They were working on stuff. Did you guys get 14 root 18?
Yes, ma'am.
Did you break 18 down?
Yes.
no. I'm working on it.
Is there a perfect square that goes into 18? Oh, thanks so much for not saying 6, guys. Why are you looking at me?
Well, it's like, I thought you were gonna work it out.
No, I was letting them finish. $42 root 2? Woo! Alright, now let's look at this page. This page. Please do number 32 and 18. See if you can do 18. I have faith in us. And 4. 32, 18, 4. Unless you've already done 4.
So 32, 18, 4.
Yes. I wish this was a real wand to turn you into a toad. I'd probably like you more if you were a toad. They don't talk. They just hop around all happy, ribbiting.
What's that noise they make?
A ribbit? A croak? What is wrong with you?
32.
No, 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 no. I'm not going to say that out loud. For 32, did you guys get 10? Because 5 times 20 is 100 and the square root of 100 is 10?
I'll keep forgetting about the like.
Take the square root of perfect squares? Yeah. Alright, let's look at 4 before we go to 18. So 6 times 20 gives you 120, right? So you have the square root of 120. The biggest one that goes into that is 4. 4 and 30, so you have 2 root 30. How'd we do there?
I thought, no, that can't. Really silly, but no. I'm more.
Alright, so what did you guys do for, Blair? What did you guys do for 18?
I just love the exponents.
You added the exponents, so you have x times x cubed, and that gave you x to the 4th, right?
And then you got y to the fourth.
And then you got y to the 4th, and then you take the square root of those?
Yes, ma'am. So
Yes, they're
x
perfect
squared
squares.
and y squared.
X squared, y squared. How many of us got that as our answer? Hey, good job. Saxon, can you work that one out on the board for me, please?
Yes. What number was 18? Okay, yeah.
What do you think will have you put on yourself? What is it? That means.
Then you simplify 4 and 4, which gives you screw x to y to.
It shouldn't be the square root of it.
Damn.
It shouldn't be the square root of it.
Huh?
It's just x squared, y squared with no radical.
Oh, I
because
didn't.
you took the square root.
I didn't mean to take this. I didn't put that on my paper. I swear.
We know where my whiteout is.
Keep going.
Look like more
I
paper.
think it fell under the. Oh, it's right here. So it should not have a radical over it. It should just be that. Does everybody see how we got that? Are you sure? Do we need to do one more together? Are we ready to move on to distributing?
Let's do one more together.
Do one more? Together? Why? Hi.
Alright, hello.
Okay. I'm gonna put C right here. And I'm gonna say 8 square root of 3 times 9 square root of 7. 17. 8 root 3 times 9 root 17. We added a problem right here.
Oh. Okay.
Sweet potatoes.
Sweet potatoes. Is that 9 root 7?
9 root 17. Are we done? What, 41? 51? 51. And does anything go into 51? Ta-da! How do we feel? Are we ready to distribute? Okay, so you distribute the same exact way. So we're going to multiply this 3 root 5 times the 2 root 5, and then we're going to multiply 3 root 5 times 5 root 3. Now, can we multiply the 3 outside the radical and the 5 under the radical?
No.
No, you cannot, but we can multiply what's on the outside and what's on the inside. It's magic. Alright, so what's 3 times 2?
6.
What's root 5 times root 5? And what's the square root of 25? So it's just 5, right? Does everybody see where we got that from? Do we need to walk through it one more time? Alright, now 3 root 5 times 5 root 3 gives us 15 root 15. Because the square root of 5 times the square root of 5 is just 5. Exactly. Because the square root of 5 times the square root of 5 is the square root of 25, and the square root of 25 is 5. Alright, 6 times 5 is?
30.
So 30 plus 15 root 15 is, that's our answer.
That's 5.
Nope, you can't combine those. Why can you not combine these two?
It doesn't have a root.
It doesn't have a root. It doesn't have a radical. What am I? Let's do the next one. Can you try it without me, or do you want to do it together? Together? Let's do it together just to be safe. Alright, you do 3 root 2 times 4 root 3. So you do 3 times 4, and you get? And then root 2 times root 3 is? Root 6. Plus, alright, what's 3 times 6? And what's root 2 times root 2? 2. So then it's 12 root 6 plus 36. Ta-da!
Hey.
Hey, how you doing? Fantastic. Yes. We can also foil radicals. It's easy. I'll show you next. Alright, please do 15 and 16. It smells so nice. Alright, so for 15, I got, cover up everything else. I got the square root of 12 plus the square root of 18. And then I broke that down into 2 root 3 plus 3 root 2. Okay. Anybody else get it right besides Dalen? Does anybody see their mistakes so they know what to do next time? Awesome. Good job on both counts. Are we ready to look at 16 or do we need another minute?
Come on, unveil it. Unveil it.
Unveil.
Unveil it.
Feel it.
Reveal it.
Yes.
6 plus 2 root 6. So the, the square root of 8 times the square root of 2 is the square root of 16. The square root of 8 times the square root of 3 is the square root of 24. The square root of 16. Ah, that should be a 4.
I got it right.
Alright, 4 plus 2 root 6. Did we get that one right? Woo! That's exciting. Do we need to do one more? Does anybody need one more? Okay, we can do one more. Alright, so I'm going to write it on the back of this. It's going to be distribute C. Alright, let's see.
Oh my goodness. That's so cheesy.
Yay! Can we move on? Okay, yes, I will happily explain it. You do 5 times 3 and you get 15. Root 3 times root 2 and you get root 6. 5 root 3 times root 3 ends up 5 times 3, which is then 15. So you get minus 15. Do we need to do one more?
No.
Are we sure?
Yes.
Y'all ready to move on to equations? Okay. You asked for it.
Is it harder?
No. Okay.
You write that word period. I am now.
What should the topic be?
What do you think we're talking about?
Yeah.
Look at the paper and tell me what you think the topic of this is.
Biology.
Radical equations.
What's going to call a radical?
We're gonna call them rad equations. They're rad.
They are. Alright, so let's label the parts of the radical. What is that 3? What's it called? Starts with an I.
That little
Index. Alright, what's the number under the radical called? A radicand.
we need to have a point back.
Right?
Yeah, man.
Alright, so these are examples of radical equations. It would be like x plus 2 equals 5. The square root of x plus 2 equals 5. Or the cubed root of x minus 7 plus 2 equals 9. Notice that my hook ends. That plus 2 is not under the radical. So today we're going to learn how to solve these.
Yay!
The Dalen is a pain. That's my translation. Alright, now to solve an equation that involves a variable and a radicand, we must get the radicand on one side of the equation alone in order to solve. So it's just like when you have a variable and you're trying to get everything away from the variable, you still do the same thing. Solutions that result in a false statement when plugged into the original equation. So if you get two answers, because you can, and you plug them in to check, and one of them gives you a false statement, it's called extraneous. Isn't that a lovely word? It is an extraneous solution.
That sounds like extremes. Extremes? Extremes.
I know. Sad day. Alright, so to solve them, what you have to do first is you have to get everything away from the radical. So on the first example, we need to move that minus 4 because it's not under the radical. So we would add it. And you're left with the square root of x minus 1 equal to 4. Now, who thinks they know how we might get rid of a radical? We did it the other day with conjugates. Well, yes, but what's the opposite of taking the square root?
Squaring.
Squaring it. So you square both sides. Now, why do we square both sides and not just one?
Because if you do it to one side, you do it to the other.
Yes, and that's called balancing the equation. What you do to one side, you have to do to the other. So if we square the square root of x minus 1, we're left with x minus 1. It disappears. And if we square 4, what do we have? Now is x by itself? What would we need to do? So what does x equal?
Just equation.
Alright, now before we reflect on what we did, would you guys like to try this one without me, or do you want to do it together? Okay, well, before we start,
That number on the outside. You divide.
look at you go.
Yeah.
Because it's 2 times the radical, so what's the opposite of times? So what would you divide both sides by? Magic! Beginning. Just like we added 4 over here first in the beginning, you have to divide both sides by 2 in the beginning.
So would you just be left with?
The square root of 3x plus 15. Yes. Sweet potatoes. Sweet, sweet potatoes. Yep. Look at you go. Caleb, are you done already,
Oh,
son?
this is easy. Is the test, is the exam going to be multiple choice? It's going to be easy because if you're checking, just plug in the answers. Always do that.
So are you going to take the exam now?
Cool. Trying to help my fellow classmates.
That's nice of you. How many of us got it right?
So then you
Woo!
just plug in.
We're gonna do that in just a second. Alright, now, why do we square both sides of the equation after getting the radical alone?
No, that can't be in the speak up.
What are you talking
You can't do that, you know, you can't have it.
Forget we can do it.
I might not be the teacher, but I
I
got
forget that when you're doing equations, you do world equations backwards, so instead of this is sat map.
Yeah. That is not what you said. I don't even think those words were part of your sentence or your fragmented, broken statement. I don't know what happened over there.
We have a worksheet on this.
Yep.
This is easy. I like the equations. I don't like
Alright, now let's check it. You would check it by plugging in what x equals back into x. So we have the square root of x minus 1 minus 4 equals 0. So what did we get for x on this
Oh
one?
yeah, it's gonna be 4 because it's 16. Yeah.
Yep, easy. That's funny.
Right? X is 17. What's 17 minus 1? What's the square root of 16?
4.
And what's 4 minus 4?
0.
We did it right. Look at us go. So can you plug -2 back into the other one and see if we got it right?
Yeah.
Do it. You need some more? It's on the desk.
Oh yeah. I just plugged it in.
Got that from Amazon. Why don't you just leave it on your desk for a moment? Just in case you need it in a little bit. Did y'all get 6 equals 6? Yay! Alright, turn the paper over.
We do it on our own.
You are! Do that first one on your on your own.
If we just like go over the answers and one
I'm gonna take.
Well, if you square both sides, what do you get?
it's x equals. Wait, x equals. Oh, 4. My bad.
So easy.
So you got 4, right? So you square both sides. You would get x equals 4. If you plug that back in, does the square root of 4 equal -2?
No.
You tell me. What do you think? 2 negatives can equal a positive, though, right? So couldn't -2 times -2 give you 4? So is it possible that it could be -2? Do you think that would be an extraneous solution or an actual solution?
Extraneous. I don't know what extraneous.
What was the definition of an extraneous solution?
So it would be extraneous.
When you string your name.
Oh, I should have printed that on. Are you sure?
Social science only false statements on to the original question.
If it gives you the wrong answer, right? So, what do y'all think?
Extremely.
Why do you think it's extraneous?
Well, that's
Really.
Because the square root of 4 is 2. So this is an extraneous solution. Work on number 2. And I had to make sure I wasn't crazy and look at my key. Because some kid whited out. I'm going to work them out while y'all work them out. Because I haven't done these in a while. But I'm going to pause the video so you can't see my answers and cheat.
I got it.
Alright, on number 2, you add 7 to both sides, and you get the square root of 2x plus 5 equals 3. And then you square both sides, and you get 2x plus 5 equals 9. Subtract 5, you get 2x equals 4. Divide by 2, x equals 2. So when I plug that back in, 2 times 2 is 4, 4 plus 5 is 9, the square root of 9 minus 7 is 3 minus 7, which equals negative 4.
Yeah, I just divided. I didn't divide one. I just divided all of them.
Alright, so for number 3, I squared both sides, and I squared both sides, and I got 1 plus x squared equals 25. And then I subtracted 1, and I got x squared equals 24. To get rid of the squared, you take the square root of both sides. So then I got x equals plus or minus the square root of 24.
I just divided them both by x.
If you didn't put the plus or minus.
Yes, but I won't count off entirely because the reason is because you can square a negative and get the same thing. That's why you do plus or minus the square root of 24, because it could be the negative or the positive. All right, are you ready to see how it plugs it in, or do you need a minute to process? Okay. Take a minute and process.